Ready? Ready? Ready?
Yeah.
Okay. Okay. So here's where we're going at. The first one, so in my two groups, I'm going to write group 1 and group 2 on my piece of paper. All right, so the first example is burning a candle. Burning a candle goes into group number 1. Now that this really helps you because there's only one word now. All right. Second thing we had was making ice by putting a tray of water into the, I should say freezer, not the fridge, but you know what I meant, right? Freezer, yeah, making ice. So making ice also goes into group 1. Not sure if that's what you guys had. All right, the next one is boiling water. Boiling water goes into group number 2. It's okay if you guys got this wrong. That is vocab detective. Okay, everyone's like, this has gotten worse. All right. Burning sugar is in group 1. We have activating an ice pack. That goes in group 2. And then the last one we had was cooking an egg, which goes into group 2. All right. I know it doesn't make sense. That's why we do it. So the magic words that were from group 1 and group 2. Group 1 is something we call exothermic. Don't freak out with me. So exothermic is what these are. And the other group is examples of endothermic. So these are types of chemical reactions. So today what we're going to be talking about is something called enthalpy, which is the energy change in chemical reactions. In some chemical reactions, they will release heat energy. So exothermic is describing chemical reactions that release, or sorry, chemical or physical reactions that release heat energy. The way I like to think about exothermic is that you are excited and you're releasing all your energy, getting all happy, all right? So when we are thinking about these items here, burning a candle, if you're burning fire, it releases heat because if you go next to a fire, you go next to a candle, you notice that there's heat coming off of it. So that is exothermic. Making ice kind of seems kind of strange because you're like, ice is cold. But in order for me to make ice, I need to lower its temperature. So by lowering its temperature, I'm taking away its heat. So that's why that one is also an exothermic reaction, which is why my brain got confused for a second. So you guys are going to make the same things that I do. Burning sugar, again, when you burn sugar, it releases heat energy. It gets really, really hot. So those are examples of things that are releasing heat energy. What that then tells me then is the opposite, endothermic, is absorbing heat energy. All right? So we are thinking about things that need heat, that take heat away. So boiling water. Yes, boiling water feels hot, but in order to boil water, you need to apply a heat source to it. So that's why that is an endothermic reaction. So be careful when you're thinking about these. You're not thinking about, is the water hot or cold? You're thinking, okay, what do I need to do to the water to get it to do that? Activating an ice pack. So when you activate the ice pack, it feels instantly cold. And so that's absorbing your heat energy. So something to keep in mind is when we are talking about cold, we are talking about endothermic reactions. So when you touch something, you're like, that's cold. It's not that there's like cold being transferred to you. The cold is the result of you losing your heat energy. So that's why things feel cold. So absorbing heat energy, thus why we're getting cold here. And then releasing energy is going to be why things feel hot. So it's all about that heat transfer. So Activating an ice pack, I activate it, I notice it's feeling cold, and that is because it's endothermic and it's taking away my heat energy. Lastly, cooking an egg. Again, when I cook an egg, I'm putting it on a pan, it's absorbing the heat to cook, and that's its endothermic. So that is the difference between these two. And I see a lot of head nodding, and that makes me really happy. Like, I know how much you guys hate vocab detective. I hate it too because I've done it. But it's really good for you to learn these vocabulary words instead of me just giving you the definitions, because that's really boring. Are we okay with that so far? Okay. And then just as a general thing that we've talked about, enthalpy is the change of heat energy in a chemical reaction. So we represent this as a delta H in our equations. Okay. So this section of structure and bonding is calculations. There are two different types of calculations we will do. There's one called the bond calculations, which is what I'm going to start you guys off with because I think that's a good kind of foundational to understand the second type. The second type I just call enthalpy calculations. There are two versions of that one. It's basically the same question, just going in two different directions. So it's like when we were talking about titration, how we did something one way and then did something in basically the reverse way. It's like that. In fact, a lot of the titration stuff is going to come back to over the next couple of lessons because we're going to be talking about moles, mass, and we're going to be talking about stoichiometry and those ratios again. Okay? Questions, concerns, comments? All right, cool. I'm going to pause it here. Okay. Yep, it's recording. All right, team, going back. Get out of the way. And what else do I need? I need my piece of paper. All right, so next thing I want to talk about a little bit more introductory stuff, and then we will be going on to do some calculations. And I'll use a past exam question so you guys can see how these calculations work. Alrighty. So, like I said, enthalpy is talking about the change in heat energy in a chemical reaction. What we need to keep in mind as well is bond breaking and bond making, and does it require or release energy? So if I am breaking chemical bonds, so if I am in a chemical reaction and I'm trying to break chemical bonds, when I do that, I need to absorb energy in order for that to occur. The way I like to think about it is I have two magnets that I'm holding together and I want to force them apart. So naturally the magnets want to come together. Just like with chemical bonds, these bonds want to happen because they're usually more stable when they're in chemical bonds. So to force things apart, that's going to require energy. So if I break chemical bonds, that's going to absorb energy. And then what that tells me then is the flip side of it, the making of chemical bonds will release energy. And then we'll look at some energy graphs. So what we're thinking about when we're thinking about why is this reaction endothermic and why is this reaction exothermic is we are comparing the energies that are in the reactants versus in the products. And the difference is either going to be the energy released or absorbed. Are we okay with that so far? All right, can I move this? So let's think about exothermic reactions. So exothermic reactions, let's say I had a graph, and this is a very common graph you guys might see on the exam, and you might have to explain it, which is why I'm going through it. So let's say I have a graph here, and I have a chemical reaction on this side. This is the time of the chemical reaction, and this here is representing the energy. If I have an exothermic reaction, what happens is I have reactants, and then a chemical reaction occurs, and then my products have less energy. So this is my reactants. These are my products. And so what that tells me is that the reactants have more energy than the products do. The reason why is because the energy that was stored in these bonds has been released to the environment. So this bit here is energy release, which we know is exothermic. So that graph often comes up. Something else you might see is like a little hump for activation energy. So you might also see something like this, where you have a little book and then down and then like that. And that's just showing activation energy. So energy required in order for the reaction to occur. So, but both of these are basically saying the same thing. If I have an endothermic reaction, then I have that graph in reverse, where my reactants have less energy than my products. So reactants, products. And so what this tells me is that this section here is the energy absorbed. Okay? And then same thing, you could have one that had a little hump of activation energy and then it goes. Are we okay with that? All right, something else to keep in mind is I'm trying to think, I think that's all I wanted to, oh no, I think I might hold that off to another lesson so that way we don't have too much on one lesson. The other thing I want us to think about is, like I said, there's this delta H, which is referring to the change in heat energy. So when I have an exothermic reaction like this, the delta H is going to equal a negative number. So this is another great way to idiot check yourself, is double check your calculations and does the calculation match what is being described in the question. So if they're describing an exothermic reaction or if they're describing that heat's being released, when you do your math, you should get a negative number. And then endothermic, the delta H is going to be positive. All right? So keep that in mind. I'm going to pause it here. Or sorry, I'm going to stop it here until we have two separate videos. So this is all the video of like introduction to enthalpy, and then we'll do a video to show you the calculations. All right, we good?